So as I said last week, we started with chapter 4 and we talked about Boolean expressions. And then we talked about how do we use Boolean expressions with selection structures. And we talked about type of selection structures. We said we have an if statement and we have if else statement, we have the nested if statements, and we have the switch statement. Today we're going to talk about repeating structures or repeating structures or loops. What are they and how many different loops do we have in Java, and when should we use one loop rather than using other types of loops? So we'll see that all the loops that we know, we simply can use them like with any situation that you could find yourself in. You can use any type of those 3 loops that we're going to cover today, but one of them is going to be more suitable than the others, and we have certain like conditions that if we just pay attention to them, we would know what will be the right loop to go with. So the first thing here, let me just go and share my screen. This is the project that we had last week. So let me just take everything out and let's start new. So loops, as I said, what is a loop? Let me just start with that. And today is 9/5. Okay. What is a loop? A loop, it's a structure, and it's a structure that's used in many programming languages, all the programming languages actually, that could be used to repeat certain operations for a certain number of times. And the concept, again, is very simple, but the use of the decision of when do I use the loops and how do I use loop could be a little bit confusing. But in general, loop is just a tool that you can use to make your program repeatedly do something. And I usually use this example. If you want to ask users to enter their name, for example, and let's say you have 5 users, and instead of actually repeating the same line of asking that user to enter his name and then repeat the question again or repeat the question again for 5 or 6 or 7 different the same line repeated different times, and instead of that, just put it in a block of code and ask the compiler to repeat it for the number of times that you want it to be repeated. And that's how simply loops are. But in reality, this is not what loops are designed for. This is a very, very simple usage word. Loops are mostly used to process data that is organized in different data structures. Loops will simply give you access to every single element in those data structures. And whenever you have access to those data, you can use them for many, many different purposes. You can predict use the data to predict something. You can use the data to apply some analysis, do some statistics, do some calculations. So loops are heavily used when it comes to processing data stored in data structures. And once we're going to start talking about arrays and array lists, we'll see how loops are going to be a very, very useful tool. So without me keep going in the importance of loops, I'm just going to jump straight into the types of loops that we have in Java. The first type of loop, we call it the while loop. And the while loop syntax is very simple. You type the keyword while, and you have a parentheses, and then after the parentheses, you must have a curly brace opening and curly brace closed. Now, in the parentheses here, you must have a Boolean expression. And as long as that Boolean expression is true, the loop body is going to be executed. Okay. And the loop body, as long as the expression that you're going to type between those parentheses is true, the execution of the body will be continue and is going to go on and go on and go on. Now, whenever you create a loop, it's very, very important that you keep updating the condition that you have here, because if this condition is true and nothing changed about it, you will end up having what we call infinite loop, a loop that would never end. And it would never end because simply whatever you have between those parentheses is true all the time, so the loop was going to go forever. So because again, having an infinite loop is not a good thing. We always need to, whatever the condition that you have here, you need to have a line in the body of the loop that will update this Boolean expression. If you have a variable there, it's supposed to be updated, just again, for the purpose of getting to a point where the loop is going to be broken. So let's just come here, for example, and say integer counter, and let's set the counter to 10, for example. And I will say, as long as counter is greater or equal 0, I want you, for example, to show me a message. We'll have an actual example later. Well, this is, again, just an example. Java is good. Now, with this loop here, if I just keep it as it is, you will find, if I run it, this line, Java is good, is going to be printed forever. Okay, it's just going to keep going. Why? Because the counter variable here is going to be always greater than 10, and no changes applied to it. So what we need to do, we need to make sure that counter will be always updated. This time I decided that I'm going to increase counter by 1. And actually, I can do something here. Let's just change this to be 1. So you're going to go from 10 to 1. And here, what I'm going to do, I'm just going to say counter plus, and I'll put, okay. Let's just take this extra space away. Now let's run it. Let's see if this is going to work. And, oh, look at that. Oh, I made a mistake. I made a really, really bad mistake here. Let me stop it. Again, I'm increasing the counter by 1. So it's going to go from 10 to 11 to 12 to 13. So no matter what you put, counter will always be greater than 10. Let me stop that. I made a mistake. This is supposed to be negative. So we're going to subtract it. Now, if I run it, you'll notice that it's going to go from 10 all the way to 1. And it's just going to repeat the same line. Now, if I want to reverse the order, I can start here from 1 and say, as long as it's less or equal 10, it's going to be repeated. And you see it's going to do the same thing, but now it's going to count from 1 all the way. Oops, I made the same mistake again. I have to change it to plus this time. Now, if I run it, I'll get it 1 all the way to 10. So this is, again, a very, very simple example of a loop that we have in Java, which is what we call the while loop. While loops are usually used when we don't know exactly how many times the loop is going to go for. It could be used, actually, for user input. For example, if I want to ask the user to enter a value, and I don't know how many times I'm going to be asking the user to enter a value, but I know if I decided, like, I'll tell the user, if you enter the value 999, for example, the loop will stop. So let's just go ahead and do this, just to give you an idea. Imagine we need to have a program that will simply ask the user to enter values, and then those values are simply going to be used we're just going to try to have the average of the values that the user is simply going to enter. Okay, so we're simply going to ask the user. So here's what I'm going to do. I'm going to say integer value. We'll set the value, for example, to 10, for example. It's just a dummy value. Or you know what? Yeah, we need it. We actually need to. Let's set it to 0. Let's initialize it with 0. Now, here's what I'm going to say. I'm going to come here and say, as long as value doesn't equal 999, I want you to repeat something here. So what are we going to do? We're simply going to ask the user to enter a value. So let's go ahead and do that. System.out.print. And we'll just come here and say, enter a value. And I'll just put a message here. And I'll say, enter 999 to stop. So we're asking the user to enter a value. And I'm going to come here and say value equal user in dot next integer. So we're asking the user to enter that integer. Now here's what I need to do. I need to come back here and create a value called sum. So integer sum equals 0. And I need to create another integer counter and set that to 0. So what I'm going to do here after that, I'm going to come here and say sum plus equal value. So I'm going to have them added up, and then counter plus plus. I want to know how many values I'm going to be entering. So this loop here is going to go, as long as I'm not entering 999, the loop is just going to continue. The moment I enter 999, actually the problem with this program is 999 is actually going to be used in the calculation. So I'm just going to put that as a comment here. 999 is going to be used in calculations. Okay, how to fix this? Well, how do we fix this? If we actually ask the user to enter the value at the end, but if that's the case, we're going to do the summation here, and yeah, that's actually going to work if I just cut it from here, because the first value is 0, and the counter is simply going to be added here. So we can't use the counter here. We'll just here. Let me cut this from here, and let's just put it here. Now this case, let's just put it that way. If I put it this way, the value that's going to be used at the beginning is simply the 0. So the sum is not going to be affected by anything, but the counter is going to be increased by 1. And that's something we don't want it to happen. Well, we can keep it here. And then by the time I'm done with my looping, I'm just going to have to subtract 1 from the counter. So, yeah, we'll, 0. Yeah, it's not going to be counted. So let's just go ahead and run this for the purpose of testing it. So I'm just going to enter values that are exactly this. Oh, I forgot that this is not completed. I just need to come here and say system.out.print line. And the average is simply going to be sum divided by counter. Remember here, those are both integers. So let me just cast the counter, for example. I would change it to a double and put a semicolon here. And now let's run it. I'm going to enter just 3 values with the exact same value. So I'm going to go 5, 5, and 5, and then 9999. And he's telling me it's 3.7, and that's not correct because it's supposed to be 555, so it's supposed to be 5. But again, the 999 here that I entered, the last one, when it went back to the while loop, this is where it was broken. But again, the counter was increased. So if I cut the counter from here and put it here, there will be no change. We'll get the same effect because after entering 999, counter is going to be increased. So that will have no effect on the whole thing. So I'm just going to keep the counter here. All I have to do here is to come to the counter and subtract 1 from it, and then change it to double. So let's give this a try again. And now if I go 5, 5, 5, and then after that 999, and now I got a 5. And it worked with no problems. Later, I'm going to show you that we have a different type of loops that will simply fix this whole thing without the need to worry about everything. We have a lot of other tools that could be helpful. And we really don't need to go through what I just showed you here. But this is, again, just a demo to show you how while loops actually could be used. Now, the other type of loops is called the do-while loop. And the do-while loop has a different type of structure. And then you type while here, you put parentheses, you put semicolon. The structure here is a little bit weird, kind of. So let's look at this. First of all, never put a semicolon in this area. Okay, this is something that some students get confused about. and you have to have a semicolon here. So make sure that you know the difference. While loop, you will not have a semicolon here. A do while loop, you must have a semicolon here. Let's put I'm gonna actually use the same example that we have here to perform this. I'm gonna go integer value 1, set it to 0, integer sum 1, set it to 0, integer counter 1, set it to 0, and then we have the do while. And in the do while, I'm going to copy this, and I'm going to put it here. And with this do while, we're simply going to start by adding the sum and then doing the counter, which again, we're going to end up with the same thing. And the expression, I'm going to use the same one that we have here, and I'm going to put it here. And I'll set that, of course, to value 1. Okay, so here we go. Let's put sum 1, value 1, counter 1, and here value 1 again. So what's the difference between the do while and the while loop? Now, the while loop, as you can see here, the expression is at the beginning of the loop. And here the expression is at the end of the loop. And this is what we call a pre-test loop, and this is a post-test loop. And the main difference between them, and let me see, why is he complaining about sum 1? Do I have someone somewhere here? No. I don't know. Why is he complaining about that? Sum 1, set it to 0. I do have, I'm using it. Oh, I didn't use it. Let me just put it here back again. Sum 1 plus equal value 1. Okay, I'm using it. Why are you complaining about this? This warning doesn't make any sense to me. The value of the local variable sum1 is not used. How come it's not used? It's here. Sometimes Java just, anyway, let me just save it. Maybe later he will figure that out. Okay, let me come here. Let me copy this and put it at the bottom. And let's change this to sum1 and counter 1. Okay, so what's the difference between a while loop and a do while loop? As I said, this is a pre-test loop and this is a post-test loop. So what is that supposed to mean? This is how it works. If I decided to come here and set value to 999, then this condition here is going to be false and the while loop will never execute. And that's a possibility. So with while loop, there is a chance for the loop to not execute at all. But with a do while loop, the loop will be executed at least for one time. And then after that, you will decide if you have to do it, continue or not. In some sort of fashion, it looks like the while loop will act as an if statement. So if this condition is true, you're going to go with the process of looping. If it's not, you're going to skip the looping altogether. Here with the do while loop, no, you cannot make that call if I should loop or not. You actually need to execute the body of the loop at least one time to know if you should continue with the looping or you should not continue with the looping. And this is the main difference between them. And now, depending on the application that you're working on, what you're trying to do, you're going to have to make a call. Should I use a do while loop or should I use a while loop? And again, as I said, if you are executing your program normally in a normal fashion, and then you got to a point where you're not sure if you should loop or not, depending on the situation, you go with a while loop. If the decision of looping relies on calculations, then you go with a do while loop. Both cases here is not applied here. This is just for the demo purpose of it. So in the do while loop, what's going to do, we're simply going to ask, we're going to increase the counter by 1. We're going to set the sum to equal value, sum plus the value. And then here we're going to ask the user to enter the new value. So as long as the user is entering value that's not 999, it's going to continue. The moment you enter a value that is 999, you're going to skip. But the problem is the counter was already increased for that extra 999 that you entered. So we need to subtract it from here. And now if I run it, I will get the exact same values and it will work with no problem. So let's go 5 again, 5 again, 5 again, then 999, and then again, 5 again, 5 again, 5 again, 999. And I got the same exact value. So this is the while loop, and this is the do while loop, and this is how they work. Now, the last loop that we're going to talk about is called the for loop. And after I'm done with loops, I'm going to go back to all these examples and show you we have more tools that could be involved with these loops. So the for loop, and by the way, those two examples that I just showed you here, you don't know, and I don't know, and nobody knows how many times the user is going to enter values until he entered 999. So those type of loops, we usually use them when we are not certain and we are not sure how many times the loop is going to be executed. So we go the while loop and the do while loop. But the moment you know exactly how many loops and iterations your program is going to go through, this is where you simply and immediately use a for loop. So for loops are simply used whenever you know exactly how many times your program should be executed. And the idea here, and by the way, if you guys have any questions on any time, please let me know. A for loop is very simple. We start with the keyword for, and we open a parenthesis and we close the parenthesis, and then we open a curly brace and we close the curly brace. That's the for loop. Now, this is the body of the loop. And this is where we're going to enter a lot of information. First of all, since we know how many times the variable is going to, the loop is going to go, we need to have a counter. And we usually use the I for a counter. And we need to set the counter for 0 or 1 or whatever you want. It depends on how you want to loop. I'm going to explain this in a sec. So we're going to start with, for example, I equals 0. And then I, as long as I is less than or equal, let's say 10. And then I will do I++, increase it by 1. So those are the 3 pieces of information that need to be available for the for loop to work. Now, what I'm doing here, I'm initializing I to equal 0. And then I'm saying, as long as I less or equal 10, since I'm going to go all the way to 10, let me start with 1. As long as I is less or equal 10, I want you to repeat whatever you have in the loop of the for loop. And every time you're done with one iteration, I want you to increase the I by 1. So for example, yes?
Do you have to initialize I in the for loop?
Not necessary, but I'm going to explain what other options that you have.
Okay.
So let's just imagine I want to enter a message, show a message on the screen for 10 times. I think I had it here. No, I took it off. So let's go ahead and put this here. Print line. And I'm going to come here and type I plus and put a hyphen. And I'll just say Java is good. And put semicolon. So I know that I want this to be repeated 10 times. And let me just run it. And here I'm just going to enter 999. 999, and here we go. Java's good for 10 times. Here's what you need to understand. This increasing for I is simply going to be implemented right after you're done with the body. So when the execution get to this point, this is where I++ is going to be implemented. It's going to be increased. So we started with I equal 1. 1 is less than 10. You run this program and then you increase it by 1. Now I equal 2, and then 3, and then 4, and then 5, and then 6, and 7, all the way to 10. Now you ask, does I need to be here? And the answer here, depending on what you're trying to do. For example, here I can print I. If I come here and say, let me copy this. If I put it this way, I will get an error. Simply, I is not defined here. He doesn't know what's the value of I. He doesn't know what is the I. So here's the thing. If you define and initialize I inside the for loop header, this is what we call a local variable. So it's only going to be usable inside the body of the for loop. But what I can do, I can cut it from here. and I can put it here. And this way it will work. I now has a global feature comparing to before when it was local. Since I defined I here, I can use I inside the for loop and I can have access to it. So that's why I is, again, depending on what do you want to do with I. If I is simply going to be used for the loop and you're not going to need it later, then you just put it here. But if you actually need the value of I in your program, you really don't have to put it here. So that would be number one. Now, the last thing I'm going to talk about, those loops are very, very similar to each other. And I can tell you, no matter what problem you have, you can convert it. You can use any of these loops and it's just going to work with no problems. Even for loop, even though I said it's usually designed for a specific number of iterations, but still we can use it just like how we can use the do while loop and the while loop itself. What I can do, again, this is again just something I can do. I can take all these out and it's still going to work. For example, I can take this one from here. Wait a minute, no. I put the semicolon here. Let me cut this. And I can come here and put I++. And it's still going to work. And if you look at this one, now it looks like it's a while loop. So here we go. The bottom line, what I'm trying to say here is that either one of those loops will work with any condition you may have. But the rules and recommendations are the following. If you know how many times your iteration should go with for loops. And usually for loops will work perfectly with data structures. You have a list of 10 students, go with a for loop. You have a list of 10 employees, go with for loops. You have a list of 10 courses, 20 courses, go with for loops. When you know exactly how many times you want your program to iterate and to loop, you go with for loops. The moment you don't know, you go with while loops or do while loops. And again, it depends on the situation that you have. So those are the main three different types of loops that we have. And a thing that I want to say here that this I++, it's not necessary to be I++. It could be I plus 2, increase it by 2. So if I run it, you would notice that there will be some sort of skipping. 1, 3, 5, 7, 9, and then he showed me 11 here because I is defined here. And 11, it's where the I gets greater than 10. So here we go. It was printed here. So again, depending on the situation that you have, you're going to have to decide how you're going to update the value of I. Since we're talking about what they call the for loop, you should know that we have a special type of loops called the nested loops. And nested loops, it's simply when you have a loop inside a loop. And nested loops are usually used to process two-dimension data structures. And if I want to put it in a different term, tables. So let me just show you an example here. How do we use nested loops? Let's just imagine I want to print the timetable of 1 and 2 and 3 and 4 and 5. Okay, that's my goal. So let's go here for integer. Let's say r equal 1. As long as r is less or equal 5. So we're going to start all the way from r equal 1 to 5, r plus plus. And then what I'm going to do, I'm going to come here and say for another integer, we'll call c, for example, and c is going to equal 1. C is less or equal 10. And then c plus plus. And we open a curly brace when you close it. What I'm trying to do, I'm going to try to print 1 multiplied by 1, multiplied by 2, multiplied by 3, and 4, and 5, and 6, all the way to 10. And then after that, I will change r to be 2. 2 multiplied by 1, and 2, and 3, all the way to 10, and so on. And I'm just going to print them in the form of a table. So let's go ahead and do that.
I have a question.
Yes.
For the variable inside the for statement, does that need to be local or can you initialize it
One sec, please.
before?
Let me just increase the volume here. Can you repeat your question again?
Does the variable inside the for loop have to be local or can you initialize it before? That way you
Yeah,
can use it.
it's okay. If you want to go use it global, you can define them here and it's still going to
Okay.
work.
Okay.
So system, it's just not recommended to do that unless you have to. Having like a lot of global variables, again, if it's not necessary, it's just going to reserve the space for those variables inside the memory. But when you create a local variable, like for the R and C in this case, the moment you're done with the loops, the space is going to be freed. Dot print. And here's what I'm going to do. This is very, very critical. And I'm going to do the following. I'm just going to print R plus, and I'm going to put the multiplication operation plus C plus, remember here, the plus by itself is just going to print them together, plus equal plus, and now I'm going to open a parentheses and I'm going to multiply R multiplied by C. And then after that, plus, and I will put a backslash. You know what? I want to go with tab, but I don't know if I'm going to have enough space for it. Let's do that for now. So this is going to print 5 different multiplications in a single line. Once I'm done with the single line, I need to go to the second line. So what I'm going to do, I'm simply going to come here and copy this operation. And I'm going to come here and I'm going to put print line. So it's going to go to the next line. Okay, this is a nested loop. Let me just show you the results of how is this going to look like, so you will understand and have an idea. So let's go here, 9999, 999, and here we go. Look at this. Wait a minute, did I make a mistake here? So 1 all the way to 10. Oh, I switched it. It's okay. So here it is. This is the timetable of 1. This is a timetable of 2 and 3 and 4 and 5 all the way to 10. If I want to do it differently, yeah, this is going to go all the way to 10. So instead of that, I could come here and put this to be 10 and this to be 5. Let's see how is that going to work. 999, 999, and here we go. This is a timetable of 1, timetable of 2, timetable of 3, timetable of 4, timetable of 5. And of course, if I want to just come here and put this as 10, I will get them all printed on the screen. And here we go. To make it even look better, let's just give it a double tap. So we'll have extra spaces. And again, 999, 999. That was way too much. Now I have to push it all the way, but here we go. Let's just take one of them away and just add some spaces to make it easier. Anyway, so this is what would be my nested loop. Now, and when we get to the chapter where we're going to talk about arrays and 2-dimensional arrays, this will make more sense. But this here is just an example to show you that we simply can use the loop inside a loop. And if you think about it here, the first loop is going to go from 1 to 10, and the second loop is going to go from 1 to 10 as well. So the system, the print that you see here is simply going to print 1 row all the way to the end. And then once you're done with that, you go to the next line and you repeat the same lines again. But this time, the first time R was equal 1, and the second time R is going to equal 2, and the third time R is going to equal 3. And for each time you go with the value of R, you're going to go for values of C that goes from 1 to 10. And that's how we end up having the table that you see here. Okay. Let me keep going here. Validation. Let's have an example of input validation, because loops are usually used a lot with input validations. So what is input validation? Just imagine I want to have a program that will ask the user to enter a value, and that value should be greater than 0 and less than 100. Okay, so let's go ahead and do that. Integer, let's call it x, set it to 0. And I want to ask the user to enter a value. And then based on the value that the user is going to enter, if he entered the value that is acceptable, then I will just stop the whole thing. But if he entered a value that is not acceptable, I need to ask the user to enter the value again until he entered the acceptable value. So before I decide which loop I should use, I am simply going to do the following. I'm just going to copy this and this. Now let's go down here and enter a value. And let's just put a message here. And I'm going to put the value, for example, greater than 0 and less than 100. So this is the value that the user should enter. And then after that, we'll say x equal this value. Enter that value. Now, if the user decided to enter a value, let's say 5, 6, 7, that would be acceptable until we're done. We got x that we want. But if the user decides to enter a negative value or a value that's greater than 100, then we simply cannot accept that. So the question is, should I use a for loop, or should I use a while loop, or should I use a do while loop? In a case like this, obviously you will not use a for loop because you don't know how many times the user is going to actually enter a value that's not acceptable. And again, you don't know how many times the program is going to be executed. So we're just going to skip the for loop. Now the question is, should I use a while loop or a do while loop? Now, this is where we have to make a decision. Based on how we understand the question here, we're simply saying if the user, we're asking the user to enter a value, and based on the entered value, we're going to decide if we have to repeat the same thing or not. This one sounds like a good condition or a good case, sorry, for a do while loop. Not that I cannot use a while loop for it. It will work with a while loop, but it's more of a do while loop. I'm going to go and show you how to use a do while loop. And then after that, I will tell you, if I want to use a while loop, this is what I'm supposed to do. So we'll go with a do, open a parenthesis, and this is going to be the body of the do while. And then after this, we close it and we type while. And then in this case, we're just going to come here and type x, as long as x is less than 0 or x is greater than 100, we want you to repeat it. So if the user entered a value that is less than 0 or it was greater than 100, so both cases are not acceptable. So if he did one of them, then we have to ask the user to enter a value again. To save myself some time, I'm going to just run this one here. So let's just go ahead and run it. So enter a value. Well, I'll put -9. Enter a value. I'll put 100. And enter a value. -90. Enter a value. 200. Enter a value. 4. And it's done. Okay. So let's just come here and let me show you the value that it was entered. And let's just put X here. So you can see here, somehow I was able to force the user to enter a value that is acceptable. Okay, now the question is, can I simply use a while loop for this case? And the answer will be yes. And here's what we can do. I cannot, well, yes, I can actually. I can come here and say integer, sorry, not integer, while X is less than 0 or X is greater than 100, I'll just put those conditions here. And that should work same way. Okay, but again, it makes more sense to use the do while. Because again, we initialized x with 0, but the question is, what if x is not initialized with 0? What if x was -5? So this is never going to execute, and you would never get the user to enter the value that you wanted. So I'll do while again. Your decision about the repeating process will rely on the action the user is going to take here. If the user decided to enter a value that is acceptable, then we're done. We don't have to continue with the process. But here, if the user again decided to do the same thing, but again, this whole thing again relies on this condition that you're testing before you actually go and use the user. So if this condition became false for any reason, then the user will never have a chance to enter the value that you want him to enter. So again, this is why a condition like a case like the one that I'm showing you here, a do while will be a better choice for you. Let me see. I'm checking the PowerPoint as I'm going through the process, and there is one issue that the PowerPoint that we're using here didn't talk about, and I think it should be mentioned here. We have two keywords, are very, very special keywords that we use with loops. And again, for some reason, the book that we're using decided not to mention it or talk about it. And those two statements and tools, one of them is called break, and the other one is called continue. And the break and continue simply works, each one of them works in a different way. What I'm going to do here, I'm simply going to start with the use of the break. Let's start with the break. So let's see here. I want to take an example here to use the break. And I am simply going to use this example here. So let me just cut this from here. And I'm going to put it here. Okay, now let's look at this example here. We said one of the problems that we have here is that the counter, when we enter the value of 999, the counter will always be used. And this is something we don't want it to happen. So here's what I'm going to do. I'm going to cut those from here, and I'm going to put it here. And what I can do, I can come here and do the following. I will say if, look at this. If value double equal 9999, I want you to break. Break simply means leave the loop. And if so, for example, you're asking the user to enter a value and the user simply entered the 999 at any point, you'll immediately follow that with a test for the value. If the user decided to enter 999, simply it's going to be breaks. That means those two will not be actually updated based on the 999 value. So we don't really need to have the subtraction anymore.
I have a question.
Yes.
Does the break only break out of the if statement or the while statement too?
It's not for the if statement. It's for the while statement.
Okay.
The breaks will get you out of looping, not an if statement.
Okay.
Yes. So let me just show you the executions of this line. Now, in a lot of cases, let me just run it for now. I'll go 5 again, 5 again, 5 again. In fact, go 999, and you'll see it worked with no problems. Let me just put 7 here so this will work. Okay. In a case like this, usually you will feel like there's a redundancy here and here. And what we like to do in a case like that, we can convert this by typing true with uppercase T. My bad. True, lowercase t. So this is an infinite loop. This loop is going to go forever. But since we have a break statement in the middle that relies on a value the user will enter, then you can break. So this is totally acceptable. You can have a while loop that's going to go forever. You ask the user to enter a value. So as long as the user is not entering 999, then the program is simply going to execute. and run. The moment you enter 999, the system is begin true, and you break and you leave. So that's what the break statement is all about. We usually use the break statement in looping whenever you feel like you have a condition where at a certain value, you should stop the whole process. Okay. For example, you're counting something, and as you're going with your counting, and you tell yourself, the moment I reach to this specific value, I want to stop the looping process. Okay. And that's where the break is going to be used. Now, the continue is a different story. And what I'm going to do, I am simply going to come here, and I'm going to put an if statement here. In this example, we are asking user to enter values. And those values, again, any value that's going to be entered is going to be acceptable unless you enter 999. And that way, 999 is going to break the loop and you're going to leave. Now, imagine the situation that I'm going to explain here. Imagine you want to ask the user to enter values, but as long as the values that are entered are not, let's say, 5 or 17, okay? Those are just numbers. They popped in my head. So enter 999 to stop, and I'll just put an extra message here. If entered value is 5 or 17, don't use it. Here is another condition here. I'm saying here that the user will enter values. The value 999 will get me outside of the loop. But if the user decided to enter 5 or 17, I don't want 5 or 17 to be used in the calculations. So how do we set the situation here? It's very simple. Just like how we had an if statement for the break, we can have a new if statement. We'll say if value double equal 5 or value double equal 17. What I'm going to do, I'm simply going to type continue. Now the question is, what is continue? And of course, this is not Python. What is continue? Continue simply means whenever this condition is true, I want you to skip any lines that we have after the continue and go back to the beginning. So break will break the whole loop, and you're going to just continue with your program. Continue will skip the lines that you have here. So simply, if you enter 5, sum is not going to be affected by that 5, and counter is not going to be affected by that. And if you do the same thing for 17, the same thing will happen. Again, for some reason, 5 and 17 should not be used. So if I just run this program again, and now here's what I'm going to enter. I'm going to enter 10, 5, 10, 17, 10, and then after that, 999. And you would notice that the average is actually 10. So 999 got me out of the loop. 17 and 5 were not calculated. So the average was simply this 10 and this 10 and this 10. Continue again. It's used to skip iterations. Break is used to break out of iterations. I'm so sorry. My door ring bells. Okay. My wife is going to take care of that. Okay, so here we go. This is what loops are all about. This is, again, what loopings are all about in Java. There's nothing different than any other programming language, especially C++. It's very, very similar to what we have in C++ with what we have in Java. The decision that you're going to have to make to choose which loop, again, relies on the situation that you have. And again, it's something very simple, not that complicated. And let me just go and talk about what are the requirements for this week. Now, by default, let me just share my page, which is this one. If you go to the class page, go up, go up. Come on. I want, oh, how do I move this thing? I have that bar for Zoom that's covering my, right, here we go, it's gone. So if I click on syllabi, if I open this page, you'll go to the bottom. This week, we are supposed to cover chapter 4, which we did, by the way. So by now, we're done with chapter 4. Now we have exercise set 2 and project 2. So let's go ahead and have a look at that. Now, the previous week requirements are already like due, so I'm going to grade them probably this weekend or maybe tomorrow. I'll make sure that I put everything. All the grades are going to be updated. Let's go back here. Let's go to the assignments. So project 1 is supposed to be a submitted, and homework 1 is supposed to be submitted. So I'm going to try to see if I can grade them this week. Hopefully I will. Now project 2 is available and homework 2 is available. Now, if you click on homework 2 and you open this page, you are simply asked to chapter 3, page 115. There are 2 questions that you're supposed to answer. So homework 2, again, is still chapter 3, nothing from chapter 4 yet. I want you to go ahead and have a look at it. And then project 2, which is going to be available, if you open it, to something very simple, not that complicated again. You're simply going to be asked to create a program that will calculate a satellite volume and a satellite weight based on information that's going to be entered by the user. So this is, again, a very, very simple and easy project to complete. We're probably going to work on this next class. It's available right now, but we're going to work on it next class. Let me close that. And let me go back to Eclipse, and let's have a final example here about loops and how do we use loops in actual applications. So I'm going to come here. Oh, by the way, I forgot to say something. If you go to, I think it's modules, and if you go to the bottom here, I added this section here about videos. I had a project that I would just create a video about it to demonstrate the use of scanners, variables, constants, and arithmetic operations without any logic operations. It's about a business for lemonade stand. So we have a lot of input data, and I simply asked to create a project for that. So in case you haven't seen this video, I highly recommend to have a look at it, because I try to break down this whole concept of converting a simple project into an actual program as simple as possible. So you have here, you can have a look at it. If you just click on it, click here, a new window is going to pop, and you can watch the video. Let's see here. I don't know about the resolution, but I hope it's good enough. We have a question here. I was denied to access this video. Oh, really? Okay, I'll see why. It should be available because I decided to share it. I hope that's not the case for everybody, but I will. I'll try and see how can I make it available and accessible for everyone. Okay, let's go back to Eclipse. Okay, and let's see here. I'm gonna look for an example to demonstrate the use of looking at the book, see if I can find any example to demonstrate problem description. Well, the one that I'm going to answer has nothing to do with loops. It's actually something related to the switch statements. It's an example that we have in the PowerPoint. And let me just open the PowerPoint itself. Well, I think I have it here. Where is it? This one is called Chapter 4. Okay, here it is. Let me share this page. Can you guys see the PowerPoint?
Yeah.
Okay. Let me just jump straight to the program that I want to look at. And now this, here it is. So the idea here is that write a program that reads in a zip code and use the first 3 digits to print the associated geographic area. So if the zip code begins with 0 or 2 or 3, that's the East Coast. 4 to 6, that's the Central Plains area. If 7, that's the South. If 8 to 9, that's the West. Anything else? Well, how would be anything else? We're talking about the first digit. Oh, 1 is not acceptable. So I'm guessing 1 is not acceptable. Yeah, that's the only one that's not acceptable. So this is the case that we have here. If we want to convert this into a program, well, we can use if statements, and we can use nested if statements, but this is a case for a switch. It's a better case for a switch. Okay, so how do we answer this question? Well, the switch statement that I showed you last week, it's kind of like old style. There's a new style of switching. It's still acceptable, same results. So let's see here, how is that going to work? I will need this with me. So I'm going to copy that. No, Control Z. Copy that. And let's move on to Eclipse. And here we go. So 0 and 2 and 3 is East. 4 and 6. Central. 7 is 8, 9. And other is invalid. So here we go. This is my condition here. And what we need to do, we need to create a string. And we're going to call it zip code. Now, the reason I'm going with a string, because it's easier to extract the first character with a string comparing to an actual integer. Of course, I can do it easily if I know the size of the zip code. Size of a zip code is 5 digits, I believe. So if I just take the number zip code that you're going to enter and divide it by integer by 1,000 or 10,000, I will be able to extract the first digit. So that will work. So what I'm going to do, I'm actually going to use that technique instead of strings. The PowerPoint that you have here is actually using strings. I'm going to make it using integers instead of that. So integer zip code. Now, the problem, again, if I use integers, if the user decided to go and enter a value, well, yeah, it's still going to work. Let's just keep it that way. Zip code. So that's, again, my variable. And I need to have a variable for the first digit. So an integer first digit. We don't know what is that value, but again, it's recommended to set everything to 0 here. Now I'm going to ask the user to enter the zip code. So I'll just copy this enter a zip code. And I'll just put here 5 digits. This is just a message, so he would know that the zip code should be 5 digits. Copy that. Control V, equal, and what is our user in, I believe. Let's copy that. V dot next integer, and the user will enter the next integer. What I'm going to do, I'm going to say first digit, copy that, equal the zip code that was entered divided by 1,000. Actually 10,000. So I'll get the first digit to be separated. Now in this case, switch first digit, and open a curly brace and close it. And let's go ahead and I'm going to use the new, for example, case 1, 2, and 3, and arrow. And then we'll go and say print system. I hope I'm not. Again, I'm following what the book is telling me, but I'm not sure if this is actually the right way or not. Let's just go ahead and print line. And yeah, actually, it looks like it's acceptable. So I'll just put East Coast. Control D. Okay, that worked.
Switch uses integers. Is that right?
What is that?
The switch use integers for
Yes.
their for the
We
cases
said
they have integers.
switches can't. The only thing switches can't not use is numbers with decimal points.
Okay.
You can use
So,
it with.
but it has to.
What is
It
that?
has to be a number.
Yes. No,
It can't be like
even
case
strings and
A.
characters is okay.
Oh, characters. Is that char or like,
Yes, char.
Okay.
That's acceptable as well. Only numbers with decimal points is not acceptable. Now, this is the new style of switch statement. Previously, the previous switch statement, which still works, you have to do it this way. And then you tap whatever you want to type, and then you have to follow that with a break. Okay, so this is way more compact and better comparing to the old style. So we'll just go with the new style right now. And you need to know both of them, because sometimes you may see a code that goes back in time, get you confused. So you should know how it used to be done and how it's actually done these days with the new versions of Java. So we'll go with the second case. This time the case is going to be 4, 5, and 6. And we'll just copy this here. We'll see after we're done. How is this going to work? We'll just give it a tap here. Now, this is not East Coast. This is a Central Plains area. And V. We have case 7. And that will be south. South. We have 8 and 9. Let's just copy this. Okay, 8 and 9. And this is west. And then we have the default. And we'll just put invalid. So let's copy that, put this here, give this a tap, and we'll just put invalid zip code. So if the user entered a number that started with, well, 1 is acceptable here, so I made a mistake here. Yep, it's supposed to be 0. That was my mistake. If the user entered a zip code that started with 1, or entered a zip code that's less than 6 digits, 5 digits, sorry, or greater than 5 digits, you will get the invalid. Well, actually, no. This is not going to, if the user entered a value that is less than, let's just give this a try again for the sake of trying. And let me just come here from this point. Let's convert it into a comment all the way to here. Okay, let's take this one away. Take this one away. I'll take this away all the way. I don't need that. Let's just go ahead and close this. Oh, what's going on here? This is the beginning of it. Where's the end of it? Oh, Control Z. Just put it back the way it was. Okay. Let's run it. And now he's asking to enter digits. I'm going to go with something acceptable. 1, 2. Okay, not 1, 2, 3, 4, 5, 6. That's the East Coast. Okay. Let's run it again. This time I'm going to put 1, 2, 3, 4, 5. That's invalid. That's okay. Let's enter a zip code that's actually more than 5 digits. 4, 4, 4, 5, 5, 6, 6. Invalid. That's acceptable. Here's the problem. If I enter the value that is, let's say, 2, 3, 4, he's going to tell me that's the East Coast. The reason why he's telling me the East Coast, because by dividing the 3 numbers by the 1,000, you will get the 0 as a result for the first digit. So this is the problem, and this is why you may want to think and consider using a string instead of actually using an integer. Now, of course, if the user entered a value like if you go with a string and the user decided to enter a value that's greater than 5 digits or less than 5 digits, then it's still going to work, but it's still invalid. So this program needs to have a little bit extra work here to make sure that the number of digits that were inserted are acceptable. So that's the first thing you have to do before you get to this step here, is to make sure that the user entered a value that is acceptable. And I think this is a good use for the do while loop. So I'm going to ask the user to enter the zip code, and then here I'll put a while loop. And I need to do some calculations here for the number that's going to be entered. I need to know how many digits are exactly entered. And it has to be 5. It must be 5. But again, what if he started by entering 0? Well, that is going to be an issue. Because again, when I tried the 2, 3, 4, yeah, either way, we're going to have issues. Let me just put it that way. If I go with integers or if I go with strings, but with strings is going to be a lot easier, because with strings, I can test the length of the string, and based on the length of the string, I can tell if the zip code was acceptable or not. So I can easily fix this by converting this to, oh, wait a minute, let me just Control Z. I don't want to delete that part. Let me take this one away. Take this one away. Now I'm at a point where I believe using a string will be a lot easier. So I'm just going to come here and put this as a string. And let's just take this away, and I'll put this as a character, CHR. And we'll take this away. And now this is going to be into next. and it's going to be red. I don't need to do these calculations anymore. All I need to do here is to set the first character to equal zip code dot character at 0. So he will read the first character. And this is supposed to be lowercase c. Now all I have to do here is to come at each one of those and replace it with a single quotations. And still I can find out some issues that we have here, but I can fix them later. I just don't want to hold you guys more than this because the time is over. So I'm going to keep it to this point, and the next class I'm going to start from this point to show you how can we actually get this done. So let me stop sharing. 7:15, so this will be the end of the class of today. Next class I'm going to continue with this point, and we're going to work on the project for this class. Hopefully within the hour and 15 minutes that we have, we'll be able to get that part done. I'll try to figure out why the videos are denied. I tried to upload them to YouTube, but for some reason they were uploaded with no sound, with no voice. So I'll see how do I fix that. Let me stop sharing.